A spring of force constant K is stretched by small length x. Stretched by small length x. Then the work done in stretching it further by a small length y. That means initially the spring is stretched by some length. How much length the spring is stretched? That is x. Now what they did now here, after x, they are doing further some more distance is stretched. Y. That means, so what will be the elongation of initial elongation? Initial elongation is how much? Initially how much is stretched here? X only. Next, what will be the final elongation? You tell me now. So that is x plus y. They given what they are saying here. It is stretched further by y. Already x is there. It is stretched further by y. That means x plus y. So we can find the potential energy. Initial potential energy is how much now? Tell me. That is 1 by 2 k x1 square. Next, final potential energy is how much? 1 by 2 k. Elongation is how much now? X plus y na? X plus y whole square. Now we need what? Tell me now. Yes, so that means what is the work done? You tell me now here. Minus of change in potential energy. So then work done, which is equal to what? Tell me now. Minus of what? Tell me now. Final potential energy minus initial potential energy. So that is given as what? Tell me now. U2 minus U1. So that is W equal to what? Tell me now here. Minus of 1 by 2 k into what? Tell me now. X plus y whole square minus 1 by 2 k into x square. Now this is a plus b whole square. Now expand it now. Yeah, we can take out 1 by 2 common. That is k by 2 we have taken common. Then you will come to be a what? Tell me now. X square plus y square plus 2xy minus x square. X square will get cancelled. That is minus k by 2 into what? Tell me now. This is y square plus 2xy. This is the work done.